Hi there, and welcome back to this second last session of the series where we will let the mathematics continue as we explore what is a hashing function. Now, at its core, it has the responsibility of taking an input or a message and transforming it by mixing it up really well into an output called the digest. Now, there are many different flavors of hashing functions. We're going to be using one called the SHA-256, and they all pretty much should have at least the following 5 properties. The first of which is that it should be deterministic. So for example, if I have a message and I place it inside my hashing function, it will produce a digest. Now later on, if I were to use that same message and place it into the hashing function, it would produce the same digest. In fact, if you and I both had access to the same hashing function and I gave you my original message and you place it inside your hashing function, you would get the same digest. It's deterministic. It's sort of like using a recipe to bake bread. You take the ingredients, you put it in a bowl and you mix it up, hashing function, and it results in a bread dough. Later on, you could follow the same recipe, placing the same ingredients in a bowl, mixing it up, hashing function, and what do you get? The same bread dough, deterministic. Now the next property is that it should be irreversible, meaning that if you have a digest, it should be impossible for you to recover the original message. It would be like me taking that bread dough and breaking it up into its original ingredients in the original state. Now the next property is called the Avalanche Effect, because a small change in an input should result in an extremely large change in the output. So for example, if my message was my name with a lowercase m, I would place it inside the SHA-256 hashing algorithm, and I would get this digest. Let's put it to the side. I'm now going to make a small change to the message. I'm going to use an uppercase M. So I'm changing one character. I'm going to place it inside the SHA-256 hashing function, and I get a completely different digest. Now, looking at these two digests, we can take a look at the next property because they are of a fixed output size. And for the SHA-256, it will be 256-bit. Now, the last thing I'm going to mention is the following, which is the property of very low chance of a collision. This means if I have two different original messages and I place them into the hashing function, they would each generate the same digest. And this should be a very, very low likelihood of happening. So that's pretty much what we need to know about hashing functions, and I'll see you in the last section in the next video as we wrap things up. We'll see you there.